Welcome to String Scale Models. I'm Jason, your host, and I do models. How is everyone doing today? I am just getting the stream going here. Let some people know that I'm live. So I gotta open up some software here. Well, the software's open. I just gotta. Well, apparently, you can open two instances of the DC meter. So that's quite interesting. So, okay, I will keep that in mind for future. So let's get the chat a little bigger here so I can see when people come in. Alright, let's go to the overhead camera and see what we got. Hey Phil, how's it going? How are you not first? You were definitely first. Unless I chatted on my own thing. Oh, I should have put a comment in saying I'm first. Alright, so I have a couple things I want to go over. Phil had a question about 0 ohm resistors as fuses, and I'm going to go over how that it's perfectly fine, and if it does see a short, that it will blow that 0 ohm fuse, and then you can use a 16th 20 watt resistor and be fine. And then I'm going to look at some of these new tweezers I got here. My tweezers finally came in. Sent Phil a pair of these, and I finally got mine in here. They showed up last night. The DT71. So as you can see here, came in, and that box is nice and soft. I tell you, they do quality work. I mean, they have issues with their software and things, but they do supreme quality work on their packaging and their overall design. But you know, their software is a little lacking. I'm hoping that some firmware comes out that expands upon some of the issues they have and changes the menu system. So here we have the tweezers. They have magnets in them. These two magnets up top that you can't see attract each other. Oh yeah, no problem, Phil. And then these two magnets here that you can kind of see in here, they oppose each other, so it gives you a nice, view of. I just want to lighten this image up. There we go. So it gives you a nice, easy grip. It has your plus and your minus. Why negative is blue, I don't know, but red is positive. It's got a nice pair of tweezers that are not 100% lined up when closed, but I don't know how I feel about that. We're going to compare these to my $300 tweezers. These cost about $80 US dollars. So here is the head of the tweezers. It's a 3.5 millimeter jack. That is a tight fit. Plug it in, it goes right into identify mode, and then it is in calibration, measure. Let's touch this here. Okay. Alright, now I see Phil's issue here. Yeah, okay, let's figure out how to get it out of calibration. I'm going to have to read these instructions too. Alright. Okay. Whatever. Okay. Firmware upgrade. I'll do a video on upgrading the firmware. Now, how'd you get it off calibration? Oh, is that what it is? I can't seem to get it out of calibration. I believe you had this same problem. And there goes that alarm. That's normal for my streams. So let's see if plugging this into a USB-C port. Now I want to see here, I have a 5-volt line here to a power meter. Unfortunately, I can't show you the power meter because of the way that it is. Actually, you know what? I probably can show you the power meter now I think about it. So if I bring this up here, unplug my microscope, and I plug this power meter in there, so we can see that it's 5 volts, 5.29 volts, whatever. So it charges 61 milliamps. Okay, so with the head plugged in, it wants to, does it, yeah, it did pull up, so I can, oh yeah, you just drag and drop your firmware on there. Okay, so that's cool. So if I unplug the head, it's going to probably try to charge it. Or not. Unless they're fully charged and it doesn't want to take a charge. Oh, you guys can't even see that meter. Let's turn that off. There we go. Okay, so you can see it's drawing 55 milliamps. So what does it draw with it unplugged? Absolutely nothing. So that is extremely slow charge, or it's a full battery. So, alright. Let's plug it back in now and see what happens. So there it goes. So that's all I needed to do was that. I'm in manual, RX mode, resistance, diode, which is I'm excited about, capacitance. There goes that camera, of course. Why not? So if I can put it, if you can see it on, let me focus that camera. Okay, you can see that is inductor. If it detects data, it will fire up. Yeah, I'm going to go on, there's automatic mode right there. Okay, hold on. No, I can't get it off auto mode. Manual mode, diode. I want voltage. FX. There's voltage. So I got it on voltage mode because that's going to come in a minute here. Hey, Crazy, how's it going? I got it on voltage because I want to do something. So these are this. I'm going to compare them in a minute to my nicer set of tweezers. These right here, these made in Canada, Elite Ones, portable LCR meter. These cost anywhere between $230 and $300, depending on where you buy them. These are micro USB rechargeable, and you can update the firmware on these too. So I want to see how much difference there is between the two. This one does not do voltage, and this one does not do diode mode. So that was the reason I wanted this. Plus, you know, getting Phil a pair, I wanted to get my own pair so I could, you know, help him out if he has any issues with it. But I want to compare it to them. But first, I want to explain something, and this meter is going to help us explain it. So let me set the stage for what's going on here. So I have a switch right here. You know, I should stop and label this box of tweezers, but you know, you guys don't want to see that, so I'm not going to do it. Okay, so let's take off this camera and put on this camera. Okay, so I got a switch here, and this should do something when I mess with it. Okay, so Let's bring this here. Let's get closer to the board. So let's go over here, and I want to look at this fuse right here. So right there is a fuse, and if we, how do I want to do this? Well, let's check it with this meter here. Here's manual resistance mode. If I come in here and I touch the fuse, it's a 0 ohm link. So that tests a 0 ohm link. Let's get the overly priced, ridiculous, only if you are crazy expensive ones, and put it in resistance mode. I always use manual mode if I know what I'm testing. And this one is measuring 33 megohms. So there you go. This one's way off. Hold on a minute. The settings are weird. Okay, so let me put it in resistance mode now. That should make a difference. So if I measure that, I'm still getting 32 megohms. So measuring that fuse with the expensive tweezers, I get an in-series resistance of 33 megohms. So they're accurate on a component level. These DT71s will, tell me the exact resistance of this component, a 0 ohm link. It's telling me a 0 ohms. If I come up here to this 201 component right here, I get my tweezers on it. If I can get my tweezers on it. I'm getting about 4K. Let's see if I can get this one. Yeah, see, these tweezers aren't as fine as... There we go. Now I'm on it. What am I reading? Yeah, it's still reading 4K. So in series, this one got the 0 ohm link, and this one couldn't get the 0 ohm link. Let's see if you can get the 100K resistor. And it reads 62K. So what about the one next to it? Reads 78K, which that's 150K resistor. So with LCR tweezers, it's not as much checking for the correct thing of the component. It's more of you check a component and you get a reading. But if you check a component and you get a extremely odd anomaly, you're going to have a problem on that line. And it takes getting used to. And I can see these two tweezers measure differently, and I'm sure if I hooked them up to the scope that their measuring frequencies are going to be totally different. So it takes time to get used to how it works. But the main reason that I sent Phil a pair was I ask him for component values all the time of stuff. And this way he can pull it off and just read me the component value, and then I can write it down for my board view paper. So, but let's look at this issue with the 0 ohm link, and I want to explain it to you guys, and then we're going to do a test with the voltage mode on the tweezers. First thing I need to do is it's time to go to school, people. It's school time. I'm going to bring up this. I'm going to get my pen. And if you have a circuit, so if you have a circuit and you have power coming in, so here's your voltage coming in, and then you have a circuit, you have some resistors, it goes into an IC, there's bypass caps that go to ground, and then, there's on the IC, and then, you know, there's lines that branch off to go to other ICs. And, you know, we'll say this is our 0 ohm link. Okay, so you have this circuit here. Well, if you want to test to see what, it's all right, Phil. Yeah, I know the scope keeps flickering. I'm trying to get a capture card for the computer to fix that problem. I'm sorry about that. It's some reason that anything I plug into the USB port now as a capture card, it flickers. I'm sorry. I'm trying to solve the problem. It may take me till the end of the year to do it, but I'm doing my best to solve the issue. I'm going to make some phone calls today and hopefully try to fix it by next week. So if you want to know what kind of power that the 0 ohm link is going to dissipate, you can disregard all of this. You don't need any of that. And I'm going to show you what I mean. So let's get rid of the grid. Let's come down here. Let's clear this. So we have power coming in. That's our voltage coming in through a 0 ohm link from the charging port of the charger. Okay, and then we have a mystery box here. Okay, this is our load. Okay, this plugs into there, and then this is basically going back to there. So typical charging on a fast charge for a Nintendo Switch, we'll say we'll do 5 volts, and it's 1.4 amps. 1.4 amps. Okay. 1.4 amps. So if I come in here and I erase this little section here and I put a amp meter in here, I'm going to have 1.4 amps on this line. Okay, so we can disregard anything about this this circuit. So if we take our formula here, and I'm going to bring up this view again because this is what I have it on. So if I take my current here and my voltage, okay, my current is what? Oh, duh. My current is 1.4 amps. And my voltage is 5 volts. 5 enter. Okay, so I have 5 volts and 1.4 amps on that circuit. That means I have 1K of resistance. Okay. Disregard the power dissipate. Oh, that's still doing kilovolts. Why is that still doing kilovolts? There we go. So I have 3.57 ohms of resistance totally on the series circuit. So if I come down here on the series circuit, I know that the total resistance RT of this circuit is 3.57 ohms. Well, I know that this link right here is 0 ohms. So the resistance on this line in this load section that I don't care about is 3.57 ohms. So if I come in here and I calculate the voltage drop across each one of these set of resistances, I got 0 ohms and 3.57 resistance. Well, I know that voltage is current times resistance, and I get the voltage across the load. Well, the current times 0 is 0 volts dropped across that 0 ohm link, and then I'm going to get my full 5 volts dropped over the load here. Oh no, I appreciate it. Yeah, I appreciate you letting me know, Crazy. Yeah, it's irritating me. That's why I decided to get a card. It's got me kind of pissed off, to be honest with you. So we have 5 volts across the load and 0 volts across this 0 ohm link. And to calculate power, we times the voltage by the amperage. The amperage is already in there. And I have 0 volts, and I have 0 ohms. That's what I want. There we go. 0 ohms. Enter. Okay. 0 ohms. And then I have amps. And I have 1.4. 1.4 amps. So if I have 0 ohms, which is right here, and I have 1.4 amps, I have 0 power and 0 voltage dropped across that 0 ohm link. So if you have a 16th watt resistor, 20th watt resistor, it doesn't matter what it is. That 0 ohm link, that fuse is going to see no power whatsoever. It is just basically a pass through, and it's going to have no voltage drop. It's going to have, probably microvolts dropped across it because there's not a perfect resistor and all that stuff. But theoretically, as long as you have a load on the circuit, you're going to drop 0 power on that resistor. So let's look at where you need the 0 ohm link. So we have our same circuit here. We have our voltage, and we have our resistor, which is our 0 ohm link. And then we have our load over here that we don't care about. We have this, we have our amp meter, and we have 1.4 amps and 5 volts. So now we look at the load here. Well, load, what if the load is short? What if it's a dead short to ground and the load is 0 ohms? Okay, well, the load's 0 ohms. So now you have 0 ohms and 0 ohms, and you have 5 volts and 1.4 amps of current. Well, the voltage has to be dropped somewhere, so the voltage is going to dip down, but you're going to get a drop across these resistors or the load. And if this is a lower watt resistor and the load is a higher rating, like a short in the chip, it's going to have some innate resistance. So it's going to have, it's going to have something that is shorting it to ground, and it's going probably to be able to absorb heat, and you could put it under a thermal camera and see that. But what's going to happen in circuit, if you short this out with a wire, the wire is going to have less resistance than the 0 ohm link. The 0 ohm link is going to have innate resistance. And then when you short it out, you are going to get the full 5 volts at 1.4 amps across that 0 ohm link. And, don't criticize me on my math, but that is how it works. So if you have 5 volts, 5 volts and 0 ohms, 5 volts, I want power. Okay, so no, I want 5 volts, 5, this software is nice, I thought it was easier. No, I don't want power. Okay, there we go. I got 5 volts and 1.4. Gives me 7 watts of power. Right here, 7 watts of power being dropped across that 0 ohm link. Unless you have a 7 watt resistor, it's going to blow that link. So therefore the link is going to act like a fuse. So that link right there as a 0 ohm in a normal working circuit, it's not going to have a voltage drop. It's going to see the current, but it's not going to generate any heat because all your resistance is going to be in the circuit. Now, if you put a 5 ohm link there, it would drop. It would it would drop, it would have a voltage drop. But being 0 ohms, it's going to have a very low voltage drop, and therefore you're going to be safe with a low watt 0 ohm link. But like I said, if the second half of the circuit after that link is shorted to ground, that 0 ohm link, that fuse, is going to see all the power. That's why you would normally want like a 2 amp fuse in there, so if it saw all that power, that it would just blow the fuse. But if it saw less than that power, it would still maybe survive. But a 0 ohm link should be fine. And then these values all change if it bumps up to 15 volts. So let's dump that. Let's put the drawing pad back. But that's basically Thevenin's theorem. The very short version of it. I didn't want to get into. I didn't want to blow all your minds with an hour long of intense math, but that sums it up on what's going on. And you can use that in troubleshooting circuits if you have a if you have a low value resistor and you're getting a voltage drop across it that is really, really high, then somewhere in the circuit something's not doing what it's supposed to be doing. So therefore something is wrong with that line. And that is a lot of what happens with data lines. So we are going to take this battery, this power plug, and this horrible USB-C meter I am not a fan of. And we are either going to blow this 0 ohm link or we're going to measure something on it. So if I plug this into here and this into here, this battery in there. Okay, so there you go. It's charging at 14 volts and is charging at 300 milliamps. And that is a 0 ohm link. So, theoretically, if the circuit went short, it should, but I'm going to show you here. If I go into voltage mode, come on, voltage. If I go to voltage and I check this link here, I'm getting 0.7 millivolts. So that's the voltage drop across that 0 ohm link. Hey Andy, how's it going? So you saw that it's less than a millivolt. So 0.9 millivolts across that 0 ohm resistor at 15 volts and 350 milliamps roughly. So as you can see, that there is no power being dissipated by that fuse at all. It's just passing everything it sees onto the higher resistance in the circuit. So when you have a circuit, the lowest resistance is going to see the least amount of power. The higher resistance, the more power it's going to dissipate. You don't need to know what's on the circuit. You don't need to know what's inside the chip. All you need to know is the overall resistance of a section that is ahead of what you want to test. So if you have a resistor and you are getting a voltage drop on it, you just need to know the resistance of what's ahead of it to see if that voltage drop across that resistor is abnormal or what you want to see. So if I checked this circuit and I read that fuse resistor thing and I got 2 or 3 volts on it with the voltmeter in the tweezer form, if I got 2 or 3 volts on it, I would know that something is messed up with the charging circuit. And now that I have these, I am going to start testing things with the voltmeter, because that was the main thing that I wanted on this, was the voltmeter and the diode mode. So now I can check voltage drops across components, and that is a very helpful diagnostic tool because I don't like doing it with the probes. So I'm going to unhook this here, and then I'm going to put this in diode mode. So voltage, RX, diode mode. So I want to come in here and I want to, these diode arrays bug me, but let's find a diode. Well, let's look at this MOSFET here. So let's see if I should get a diode reading across this MOSFET between these two legs here. Let's see if I get it. Okay, so I got nothing. Oops. I got nothing that way. I'm going to turn the tweezers around. That's why I like the rotating head on this. And I'm going to check it this way. Now I should be getting a reading, unless I'm not making a connection with the... These tips may need to be modified, because I'm not getting a connection, I don't think. Am I? I don't know. Okay, so... Yeah, I don't know if I'm getting a connection. Let's try... I don't see a bigger MOSFET. Let's try across this transistor and see if I get anything. See if I get a reading across this transistor. Okay, so there I got 1.59 volts between what I'm assuming is the base and emitter. And if I flip the probes around, I should get a normal diode reading. Oh, I get open circuit. Oh, that means it's a diode then. So, yeah, so that's open. So I was able to find the junction that way, and then this one should read open. It was a high diode reading though. So if I read it that way, I don't get anything. I'm getting the open circuit, and if I flip the probes over, I can read the junction this way, and it went into auto mode on me. I don't want voltage, I want diode. So if I come over here and I measure this way, I get nothing, but if I measure across these 2 points here, this should be collector emitter. These probes need to be modified highly. So I get, yeah, okay. So first order of business with these probes is to, let's look at these probes under here, is to highly modify them. They are too wide. If you look at, yeah, they are insanely wide. Unfortunately, they appear to be gold plated. But if you look at the tips on my other tweezers here, if you look at the tips on these compared to, like, let's see here, can you look at, see how wide that is compared to how wide that is? They're massive compared to the tips. And it makes me wonder if, oh, we are going to try something right now. Okay, so we are going to, oh wow, hey, yeah, you don't need to know exactly how the component works, you just need to know that when it goes bad to replace it. That is true, but I have a fascination to know why things work a certain way, so I am going to try something here. So I am going to pull this screw out, and I am going to get this thing here, and I am going to take out one of my extra probes from this set here. And I am going to Slide that in there. Does that fit? Yes, it does fit. Look at that. Fits like a charm. So I'm going to put that in there, and then I'm going to... Does it go like that? Oh, it goes like that. Okay, so... you know what? I put it in backwards. I don't think this is going to work because it looks like the actual thing was threaded. Yeah, it doesn't have a nut on the other side of it. Well, it's worth a shot. Okay, well, there goes that. Now I'm going to have to modify these. They look gold-plated, though. That's the problem. I would have to go and re-gold plate them. Yeah, they need to be seriously modified. Okay, well, so you can't take the points off of... Hey, Neil, how's it going? Hey, Jason, you're going too low. Laptop repair. Use the wow, 0.04 amp current draw. Wow. That's pretty low current draw. So... well, okay, so we know that we can't do that, so let's put these back up in here. And where are these tweezers? That would have been a nice little upgrade if I could have done it, but you... So let me see here if these have another... Was there another pair? Yeah, there was another pair. I want to know if these are gold-plated. They appear to be gold-plated. Yeah. The same. They look small enough, but they just need more of a point on them. That's the problem. They just need more of a point on them. I'll figure it out. Didn't think I'd pick it up. So, yeah, that's that's crazy. Spipe up on it. That's funny. Oh. Yeah, that would have been worth seeing right there. So that is using those in voltage mode. So that is that in diode mode is the reason that I wanted them. But I am probably going to modify the tips on those right there. Probably going to modify the tips. So that is the tweezers. Okay, thanks, Crazy. It was good to see you. Yeah, hey, Phil, are you streaming tonight? Are you doing anything? Because I know you're waiting on that package. I'm going to turn off the flickery camera. Because that has got me very much annoyed. Oh, did the package show up that you're waiting for? See, what you need to do is you need to take every one of those 0 ohm resistors and create an individual barcode for each one so you can keep track of how many you use. That's your next goal. You need to print a label for each of those 0 ohm resistors and with an individual barcode so you can scan it when you put it on a component or on a board. That's what you need to do. And that I'm going to do something similar to that. I am going to use my label maker to print out barcodes to mark my parts. I have a that is a lot of barcodes. I have an order in for AliExpress here. Well, let's take a look at what I ordered. I ordered a lot of stuff. Let me just bring this up here and I'll show you what I ordered. So, and this is weird because I ordered a lot of stuff, but stuff I ordered way later is already almost here. So let's go to this one. Here's what I ordered. So these are the EMI filters for around P13. I believe I ordered the 50 because it was $10. So if you track that, that one is like arriving at destination. So this was dispatched on the 15th, and it's already cleared customs and on its way here. Now, if you look at the stuff, this stuff was ordered on November 2nd. If you track it, it's received by carrier, and it's not even gone through customs yet. So if you look at this, I just had a switch light in, and it shut. Oh, that's a short, man. That's a short somewhere. This one says delivering, but it hasn't even made it through customs yet. So in this bigger order, I got some metal back covers, 2 of those. I got a mid-frame, 2 of those. I got some replacement housings for some Joy-Cons, some metal brackets for the latching lock, a set of button replacements, set of speakers, and then I got some of each of the ribbon cable connectors on the board, along with the ones for the antennas. That I got a 20 piece of the BQ chip, analog sticks. I got 10 analog sticks. I got 10 of the P13 chip, some SD card readers. For some reason I only ordered 5 USB ports. That seems wrong. That seems really wrong. If I only ordered 5 USB ports, I'm going to be pissed. And then I ordered some ribbon cables. So that is what I'm waiting on, and I'm a little pissed about the USB ports. I only ordered 5 of those, seriously? I'm waiting this long for 5 USB ports? Okay. And I didn't order in any M92 chips. So, alright, Andy, thank you so much for stopping by. Oh, you can see bent pins in the port? Yeah, that's probably, let's take a look at what I have M92-wise. So, M92, I have exactly, and I didn't order any, keep in mind, I have exactly 1, 2, 3, I got exactly 5 M92s, and apparently I didn't order any. And I have 4 P13s, and I have 4 BQs. But apparently I ordered BQs instead of M92s, because BQ doesn't get changed as much. So now I have to hunt down M92 chips on AliExpress. So let's see. Well, let's just do that. Let's look for some M92 chips on AliExpress here. So let me go back to this monitor here. Let's look for M90 T36, I believe. Okay, so look at that, $529. That's fantastic. 100 pieces, $529. Let's order 500 of those. It is the T36, right, Phil? Am I getting this right? It is the T36. Hopefully he answers me. Yeah, it is the T36. Yeah, what price am I looking for here on these? Yeah, see what you paid, and okay, this guy's selling MP13s for $1.90, BQs for $2.10, and $5.60 for an M36 or an M92. I don't think I would do that. I don't know. That seems kind of weird pricing. Seems low. There's 281. What is that? Like 350 for me? It's probably 350 for me. I'm only seeing like $5 things. There's 416. And $27 in shipping. That's ridiculous. No. Why does it show in strips, but he's only selling them in 2 pieces? That's stupid. I don't like that one. Alright, yeah, I'm so not seeing anything good on here. And 1960 for 6. Is that with shipping? How many is this in this set here? What is this one? Wow, 10 pieces for 56. What is that chip? Oh, that's the 17. So 10 for 36. So if I come in here and I do, if I do 36.72 plus the $1.49 and I enter and I divide that by 10, that's $3.82. That's $3.82 a piece with shipping. And I get a $1 off coupon. Let me check the link here. Hold on. Hold on. I gotta change screens here. I don't want to show any personal information. Are they gonna ship to me? Oh yeah, $3.48. Okay, let's go this route. Yeah, that's 3. Oh, let me put it back on the screen now that the information's gone. So that's $3.48. That's not bad. They want $3.64 for shipping. How much is 10 gonna cost me? Look, if I get 10, they want $6.67 for shipping. That's insane. That's just wrong. This is 10 for 36.72 with $1.49 shipping, and I can get a $1 off coupon. But I'm going with this one for now. I'm going to add it to the cart. What is this one? 10 for $37.99 and free shipping. That's free shipping. So what is that? Let's check that out. Let's do $37.99 divided by 10. That's $3.79 a piece and free shipping. Adding that to the cart. Oh, I just saw one for $3.48, but I think that is... Yeah, see, there's too much for shipping on those. Okay, let's go to the cart and see what all I have in the cart here. I got stuff. Let's get rid of... let's get rid of this one. Let's get rid of that one. So, I got some buttons I need to get. Oh, yeah, did you see I found that FPC connector for the memory card? Did I show you that? They want $12.90 for one of them. Can you believe that? That is insane. And then I got some screens for $14 in here. Oh yeah, this is some stuff my son wanted. This is pretty cool here. This is a pretty cool Witcher set. Like you can get just the Joy-Cons, or you can get and make a Witcher Switch. I was thinking about doing it with mine. Because it's not that much work to do these. These are pretty cool. At $22 seems a little much, so I don't know if I'm doing that right now. So I definitely want those. So I want that scroll for me. I definitely don't want them FPC connectors. Oh yeah, I want these digitizers for $8.03. Ooh, $15 in shipping. Never mind. That's not cool. This one's not bad. 3 screens for $14 and $262. Let's see if they have any digitizers in their store. Why am I? Let's see, Nintendo. Spell that right. Whatever, it's close enough. Let's see what they have in the store here. Okay. Okay, so do they have digitizers? Yes, they have digitizers for $7.36. 30% off. I will take 3 of those. Add to cart. No, I don't want any of that stuff. What else do they have from that store? Joy-Con controllers. They got some replacement cables. I definitely need to get some more USB ports. So let's go back to my cart and let's check this now. So there we go. It's only, and I saved 261 on it, so that's not bad. And then I want that stuff. I don't want the buttons right now. I don't want that. This is a no-go. I want this. See, this is the lot of OEM. Oh, you have to pick up the PS4. All right, Bill, thanks for stopping by. This is a lot of 10 OEM adapters US. I was going to get these, but they want $41 in shipping. That is ridiculous because I sell bundles for my switches I fix, and I always include an OEM charger. But $14 for a charger, that is, are they going to give me any discount on that? No, just $47 in shipping. That's insane. So, so I need the USB-C ports for, so I want to go to my purchase history, my orders, and I want to order more of those dollar USB-C ports. I don't know why I only ordered 5. Okay, so what? Now, I don't know why I only ordered 5 of those. Let's go to my shopping cart now. So now I want this, that definitely, the buttons, and this. So I'm looking at, and some stuff's on sale. So $134 in parts. Okay, so that's enough of my AliExpress shopping. I am also going to look up some stuff for the Xbox and some stuff for the Switch, some other components. And I don't remember where. So I'm going to hold off on this. I'm going to go back to this camera here. I am going to actually call this stream. It has been an hour. I don't even know how many people showed up, but thanks everybody for watching. The tweezers will be in more videos. If I modify the tips, I will make a video on it. I will use both pairs. Again, sorry about the autofracting. Alright, Neil, thanks for stopping by. I'm wrapping it up anyways. So, thank you guys for stopping by. I hope everyone has a fantastic day. Thank you so much.